All right, welcome back. We're at the home stretch. This is it. We have our ASAD curve. AS is here. This is AD. We have C as a function of Y and things we know. We know what is WSS as parameters only, and R as parameters only. So we're ready to solve for Y. So all we need to do is plug everything in. Let's do it. Give myself a nicer color. Maybe I like that blue color. Use that one a lot. So we're going to have YSS is equal to CSS, which is 1 minus alpha YSS to the minus sigma L over sigma C. WSS 1 plus sigma L over sigma C plus alpha delta YSS over RSS. Okay, so our job is to gather all of the YSS together. So the first thing we need to do is get rid of this plus. So let's bring this over to the left and then factor out YSS. So we'll have 1 plus alpha delta over RSS YSS equals 1 minus alpha YSS to the minus sigma L over sigma C. WSS 1 plus sigma L over sigma C. So now we still have two YSS's. We have this one here and we have this one here, but we can combine them because we have no other addition, right? If I divide both sides by YSS, I can then pile them together into this single exponent. So as a preliminary, let's actually write this as 1 minus alpha minus sigma L over sigma C YSS minus sigma L over sigma C, okay? So I just distributed the power. Okay, and then over here I have 1 plus alpha delta over RSS YSS. So now I can divide by YSS. I guess I could multiply by this one, right? Because this minus is the same thing as 1 over. So I can multiply both sides by YSS sigma L over sigma C. Then I'll add these together and I'll get 0, right? So I'm going to have, on this side, I'm going to have 1 plus alpha delta RSS. Then I'm going to have YSS 1, and I'm multiplying by the positive. So it's plus sigma L over sigma C is equal to 1 minus alpha minus sigma L over sigma C. WSS 1 plus sigma L over sigma C. And now we need to move this chunk, this 1 plus alpha delta over RSS. Let's get rid of the 1 maybe. So we can write this as RSS plus alpha delta over RSS, right? Using the 1 trick, write 1 as RSS over RSS. So then we'll get YSS, and then I'll do the same thing here. I'll write this as sigma C plus sigma L divided by sigma C is equal to RSS over RSS plus alpha delta 1 minus alpha to the minus sigma L over sigma C WSS 1 plus sigma L over sigma C. And now I raise everything to this power, the inverse of this power. So we get YSS equals, this is it, drum roll please, switch colors, this is a monumentous occasion. How about purple? Purple is like royal, right? YSS is equal to, this has no power, so it gets everything. RSS plus alpha delta to the sigma C over sigma C plus sigma L. 1 minus alpha. Now the sigma C's will cancel, so we're going to get minus sigma L divided by sigma C plus sigma L. And then we're going to get WSS, and the sigma C is going to cancel again. We'll get 1 plus sigma L divided by sigma C plus sigma L. And we draw a box. So we now have the steady state for Y. And you see from here, we could work backwards and we could compute all the steady state values, right? We could get C and I because we now know Y, we know W, we know R. Once we know C and I, we can get K and L because we know Y, we know C, we know R, we know W. And then we're done. We have everything. So in, for example, your Python programs, when you type steady state values and you see that list of numbers, what you're seeing is you're just plugging in the values for alpha, delta, beta, sigma C, sigma L, and you're just computing what is this number. This is just one number. Right? This is a number. Once you know Y, this is a number. Once you know Y, this is a number. Okay, so you just get those numbers, and those are the steady state. And that's it. From here, you would be able to do the log linearization. And if you're interested in that, please check out Costa. Like I said, it's a good exercise to go through once and to see how it works. But in principle, you're always going to hand it to a computer. You will often want to hand the steady state to the computer because it'll help the solver to go faster. And you can do that in GE-ConPy. You can also do that in Dynar. You can tell it the steady state relationships, and it does help. So in actual practice, as an economist, the most you'll ever have to do is come to this point. And then from here, you hand it to the computer. So we're going to call this done. Hopefully that was helpful. And then in the next video, we're going to look at some variations on the theme and go through the whole solution strategy again. So you need to see this process a couple times. So we'll look at another utility function for RBC. Maybe we could look at another production function. But you should be comfortable with this set of steps. Solving for first order conditions. Solving for the steady state. Solving for the first order conditions, making that list of equations, which is the first order conditions and the budget constraints and the laws of motion of capital. Turning everything into the steady state. Solving for the prices. Clearing the factor markets. Solving for AS equals 80. Okay, and that's the steps. So thank you. I will see you in the next one.